So as I said yesterday, we talked about Christopher Alexander's work specifically, and today we're going to broaden the discussion to talk about some of the technological implications, not only of Alexander's work, but of the many topics that he touched on. And as you saw in the previous lecture, there was a very rich set of topics that revolved around this idea of Mariology or part-whole relations, but had many specific details of that, of how that structure works and how it works as not only as a static structure, but as a process. And this is something that we're now seeing applied in surprising ways in the technological world, in the world of computers and Wiki and many other aspects of technology today that I'll talk about. And some of that is directly coming through Alexander's work. But I don't want to focus too much on the fact that it was Alexander as a person who did that. I want to focus more on the fact that it was the set of ideas, the set of changes in our thinking that Alexander articulated and that Jacobs articulated and that Herbert Simon articulated and other people around this time of this transformation. Really, this is the big topic of this course, really. But before I get into that, I want to go back and revisit Alexander's work briefly, just to talk about some of his actual built work. And, you know, as an architect, it's one thing to talk about theory, but at some point the theory translates into practice, presumably. And in Alexander's case, it certainly did. And what you see is a very human-centered kind of architecture, an architecture that supports human gathering and human interaction and human flourishing, we hope, and human ability to access food and social contact and the public realm and all the things that we have been talking about, certainly the things that are in the New Urban Agenda. And also there's a heavy, heavy emphasis on the process of generating those structures, not just as a static creation of one mind, but as a collaborative process of getting out in the place itself and marking out stakes and working with people and saying, wait a minute, is this where this building would be? Look at where that tree is, look where that hill is. That might not be the best place for that, and so on. And sort of recapitulating what would normally happen in the evolution of cities, where people were taking, you know, decades and centuries to generate the structures that you would see over time, and engaging people in that process, in that crafting of sometimes their own environment. The couple in the middle there are actually self-building their own home as part of a process in Mexico that Alexander was involved in and documented in a book called The Production of Houses. The project on the lower right is a collaboration with a local farmers market owner and building this trellis structure that would support that farmers market. Actually, the one on the upper left is also in Mexico, where they're doing a very low cost roof structure where they just use strips of lattice to form essentially the concrete shell, the form of the shell, covering that with burlap and then covering that with a concrete deck on top of that. So a fairly low cost, again, self-build kind of process. So you see that in Alexander's work. You see a lot of collaborative process. You see a lot of shaping of the places for people to interact and people to gather, people to encounter each other, encounter the natural world, encounter beauty, daily, ordinary beauty, ordinary delight, a lot of color, a lot of ornament. He's not afraid of ornament because he, unlike Adolf Loos, the Austrian in the early 20th century, he thinks it is not ornament that is a crime, but the denuding of the human environment that has become a crime. And Loos, for a number of reasons we can get into later, really had the picture upside down, and and again, maybe we'll touch on that a little later throughout the course, and integrated into nature, into an ecological view of the world, of the human place in the natural world. That, you know, that we talked a little bit about biophilia, about creating places that exist comfortably within nature and within the human experience of nature as something that's integrated into those environments. And that goes not only for the vegetation, but the food and the production of the food and the farmers and the vendors that are and the people that are coming to the farmers markets and exchanging the food. This is in Fresno, California, the Vineyard Farmers Market by Richard Erganian. And some of the architecture is quite formal, quite beautiful in a sort of what one may say is sense of high architecture, the sense of almost cathedral-like reverence for structure and for form, but not at the expense of the other aspects. This is a central hall in the Asian school in Japan. And of course, it's an important space for gathering and for celebrating, for activities, for sports and so on. This is another shot of Asian in Japan. And notice how this is a very sort of Japanese DNA, if you will, and yet it's not a imitation in any sense of a particular building or type, or it's a new generation using the same kind of language, the same kind of elements and materials and characteristics. The form language, as we might say, as opposed to the pattern language, or complementary to the pattern language. The pattern language that becomes about the form, which again is what we might call the form language. Again, a very remarkable project, very much, in its culture, in its natural environment, in its setting with water and so on. Those three on the top and the one on the right are Asian school. The one on the left is another home, actually, in Berkeley. So you'll see this in Alexander. You'll see the willingness to collaborate, to generate, to create form at many different scales, including the scale of human direct experience and delight, the scale of ornament. And you'll see symmetries, and this is the Carpet Museum in San Francisco on the upper right. And those are, I don't think those are Christopher Alexander's carpets, but he was also a noted carpet collector because he was fascinated by the complexity of those forms. In many cases, some of the ideas that he got about geometric form and the 15 properties that we talked about came from his study of carpets and how they had local symmetries and boundaries and strong centers and alternating repetition, all the things that we were talking about when we were talking about the 15 properties and the nature of order. So we saw that there is a pattern language in architecture, and there is also a correlation in software, because what happened in the late 1980s and early 1990s, a number of software engineers, software designers recognized that there was a methodology there that might be useful to them, because they were dealing in many ways with the same kind of problem. How do you generate form? How do you generate a whole out of parts and avoid it becoming just a sort of a crude collection of parts, crude aggregations, because those don't work well in software. You have to have something that is well resolved as a whole, the thing that Alexander dealt with in Notes on the Synthesis of Form. How do you synthesize the form in a way that is a good fit, a good adaptation to the problem that you're seeking to address, or the problems, plural. And this is what the software engineers recognized, and they began to use pattern languages of programming. Ward Cunningham was one of the key people involved in that. Kent Beck and a number of others. There's a group called the Gang of Four that wrote a number of books at that time, quite a large collection. And instead of 253 patterns, they generated hundreds and thousands, tens of thousands of patterns and patterns in software. And in fact, in patterns of enterprise application, patterns of other kinds, patterns of system architecture. The topic really exploded actually into many different aspects of software and computer engineering and on into other fields as well. Remarkable diversity of topics, remarkable productivity of that topic. Going into gaming, most games today use a pattern language methodology or design patterns as they're called. I imagine you are familiar now because I gave it to you as a reading assignment that Ward Cunningham, who invented Wiki, was really, first of all, he was trying to develop a software tool to share the patterns. And second of all, he came to realize that the wiki itself was a kind of pattern, and an individual wiki page was a pattern, and a whole wiki was a pattern language because it was hyperlinked and it had the sort of general structure as you saw in the paper. And that, of course, led to Wikipedia. Ward was contacted by the encyclopedia people at what was then called Newpedia, and they asked him to help them to develop this new wiki-based encyclopedia that we all know and recognize. And very importantly, the structure is very similar. The page of a Wikipedia is a pattern. It's got an iconic image, it's got a title, it's got a summary statement that sort of sums up what the not so much what the design problem is, but what the thing is that they're documenting. And then there's a description, and then there's a set of hyperlinks. So very similar to a pattern structure, actually. In fact, it is, as Ward argues, it is a pattern structure in essence. And many other applications as well. The Cocoa language of the iPhone and the iOS built on patterns. Many other computer systems, many other technologies today use pattern languages. And it goes even beyond the software world. It goes into many other areas too. You've heard of Scrum, probably Scrum, and Agile methodology. Agile came directly out of the design patterns work, and Ward Cunningham was one of the key people that was a part of that development, along with Kent Beck and a number of their colleagues, who recognized that what you're doing with patterns in sort of simplifying the problem and just getting to the elements that you need to put together into the good fit of the problem. That's what you needed to do when you're creating the process as well. You need to figure out who's working together and how they're interacting, how they're doing the software, how the software is actually working rather than how it's being documented, how you're collaborating with the end user ultimately, because that's what it's all about. It's about understanding the need and developing a structure that meets the need and responding to the change over time that occurs. These are not static structures. These are processes that go forward. So this is really what Agile methodology is all about. And you probably know, those of you, I think, Dominic, you probably know some of the specifics of the sort of iterative process of Agile and how that works, and how it's based on teams. That's what Scrum is all about. Scrum came straight out of that as well. And all of this is really started out with the logic of patterns, as we saw with the paper that I really, this was a presentation that Ward gave, and I suggested that he write it up as a paper. And he said, yes, but I don't really want to do the work. Why don't you write it up and I'll edit it and we'll work together on that. So we did. We wrote this paper together. And I think that's a very important documentation of the underlying logic of Agile and Scrum and Wiki and many of these other innovations. And the basic idea, once again, as we talked about in the last lecture, is that you can document the structure of a good fit and the structure of a bad fit too. And you need good tools in order to generate those good designs. And this is clearly not a good design. I love this book by Don Norman, The Design of Everyday Things, a great book. And a wonderful cover, because a little like the door, right? With the hinges on the wrong side. If you were to try to pour that teapot, you'd be in trouble. So that is not a good fit. That's not a good configuration of the elements of the design problem. And again, with the door, imagine if you said, okay, let's put the hinges over on that side, and how would you open that door? That would be quite a challenge. Or even if you put the hinges in some crazy place and the knob in some crazy place, it's not going to work. It's simply not going to be functional, let alone be, logical and coherent and even beautiful. It's going to be weird. It's going to be, sort of a deliberately discordant and maybe you're trying to make a statement as an artist, and you're trying to be clever or whatever, but you're not solving a human problem. You're doing something very different. So again, this idea that there's a configuration, that there's and maybe a process of configuring that you need to tap into as the core of a pattern. And I'll just give you some examples that drive me crazy all the time. I just was on the plane yesterday, and this is one that drives me crazy. The reader board right in the middle of the hallway, where people stop, dead stop in the middle of the hallway. Other people are rushing to get to their plane because they're late, and they crash into the people standing at the reader board. That's a really stupid design, actually. And yet it happens over and over and over again. By the way, the other issue is that it's facing right into the glare of the windows. You can hardly read it. You have to get really up close and kind of change your angle in order to even read the damn thing. So what pattern would fix that problem? Well, here's the bad pattern. The software people call these anti-patterns. They have actually named, and I love this, I think they've actually created an important innovation there. Speaking of an anti-pattern, the reader board in the hall is an anti-pattern. It's a bad pattern. You don't want to do it. Here's a good pattern: reader board niche. You simply make a small niche in the wall, or you create a niche with some objects, maybe some pillars or structures of some kind, so that people go around it and they don't crash into the person who's reading it. The person who's reading it steps out of the hallway just a couple of feet, and then they can read the reader board. There's a good pattern. There's a solution to the problem. And yet, this is not what we're doing in our technological world today. We have non-agile technology all over the place, and technology that is failing us in many ways, sometimes in ways that are simply annoying and irritating and degrading of our well-being, just a little bit and just a little bit and just a little bit, and over and over and over again in the course of a day. And that really takes a bite out of your well-being over the course of the day. But on a larger scale, we're creating a society that is failing, a technology that is failing to be durable and beautiful and sustainable and meet human needs and meet ecological needs. It is heading us off of a cliff, heading us towards collapse on the larger scale. So I think there is a lot at stake here that goes beyond our mere comfort and convenience, and goes ultimately to our survival, our very survival, I think, at a larger scale. I do believe that. So once again, to summarize, this is a plan. This is a planning tool, a design tool, but not so much a plan of things as a plan of relationships, relationships that allow adaptive growth and change and healing and improvement of well-being, improvement of health. Ultimately, comfort is part of it, but it's not just, people tend to sometimes demean this idea of, oh, you just want to be comfortable, you just want to have beautiful things, bourgeois middle class person. No, it's about human well-being and ultimately human survival, and about whether you or not you are degrading well-being as a professional who is charged with the responsibility of the well-being of the people in your care. You are very much like a medical professional. You have a duty of care to those people. And if you are failing that duty of care, you are committing malpractice, in my opinion, nothing short. Very, very simple, ultimately. And yet we don't look at it that way. We cloud ourselves and confuse ourselves and delude ourselves with all of this stuff about, no, I'm an artist, or no, it's just what the money makes me do, or, well, what are you going to do? These are the rules. Baloney. Let's get to the core of the problem. That's what Agile is all about. That's what patterns are all about ultimately. Let's get to the core of the problem and understand it on a direct human and ecological level. And then we can begin to rebuild in a more coherent way. So this is fascinating work in the world of computers, but it goes well beyond the world of computers. There are people who have taken the pattern language methodology into the world of biology, into sociology and social change, action, product management, education, mathematics. Again, more fascinating work in biology, innovation management research, collaborative approaches, music, which is a fascinating topic for me. I started out in music in my college career, economics, conservation, environmental research, on and on and on. It's fascinating. Pattern language for weddings, pattern language for educational systems, pattern language for pattern writing, pattern language for graphical user interface. And this one, boy, this is a mouthful. Quality connector, a pattern language for provisioning and managing quality constrained services in distributed real-time and embedded systems. Okay, I'm not sure exactly what that means, but it's fascinating. And again, for many, many other fields as well, and networked learning, classroom education, again, more in the biological sciences. And this is particularly fascinating to me because as we were talking about in the previous lecture, and also I sent you the papers by Ramray Bhatt, and one of them co-authored with his colleague Stuart Newman, about taking pattern languages into the biological world. And this paper that I sent you, that you might have a glance at, Dynamical Patterning Modules, a pattern language for development and evolution of multicellular form. Essentially what they're saying is that these essential pattern modules are what life itself evolved into creating in order to generate multicellular form. This is the model that they propose for the Cambrian explosion, the point in our biological history when single-celled organisms became, and there were some multicellular organisms before that, but in the Cambrian explosion, there were many, many more. That's why they call it the explosion, there was this enormous number of new body types and new biological structures. And they are saying that a pattern-like process was actually going on at the molecular level, which is a mind-blowing idea, actually. And I think I talked to Chris Alexander about this, and at another point I asked him, what did you take away from all of your work with pattern languages? Is there any one sort of takeaway that you had? And he said, yeah, I thought I was inventing something, but I now think I was discovering something. In other words, he was discovering something about the way the world actually is and the way the world actually works, that there is this sort of pattern-like process that can go on even at the molecular level, and can build up structures and evolve structures in a certain kind of way. Really amazing, thoughtful, fascinating, mind-blowing idea. And this is another paper that Ramray Bhatt went on to write later, where he, and I sent you a copy of this as well. It's a fascinating paper where he talks about the analogy between the biological and the man-made or human architectures, and the pattern-like structure that is common to both. And also what happens when that pattern-like structure breaks down. And the fascinating thing, I think I even touched on this the other day, is that this is, at a biological level, this is what happens with cancer, that essentially you're not getting the differentiation and the reorganization into new wholes. You're getting a runaway process of replication and standardization that is creating quantity but not quality, if you will, that is creating duplication and duplication and duplication. Remember Rem Koolhaas's quote about modernism's alchemistic promise to transform quantity into quality, and that hasn't worked. Well, in essence, a cancer cell is trying to work only with quantity and in essence, transform it into quality by repetition, 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 growing, growing, growing. And the result is, of course, a process that can lead to death, death of the entire organism. Fascinating paper, and I think an important paper. So here's a fascinating takeaway from all of this discussion. So if you think about the whole realm of software designers who use pattern language methodology, it's a huge domain, as you began to see. If you just Google around, you'll see many millions and millions of hits in the pattern language of software. And then you'll see another realm that's almost as big, maybe not quite as big, of all the other pattern language applications in biology and in sociology, economics, many other fields. And then you'll see this tiny little realm, and that's where the architects are using pattern languages, myself and others. That is a curious thing, that the pattern language methodology really has not taken hold as a practice within architecture. And that's an interesting question. Why is that? What is it that accounts for this, lack of progress in the one domain where the pattern languages were invented, of course? Well, one theory is, I'll subscribe to this to some degree. Architects are weird. We have our sense of, creativity. Leave me alone. I have to do it all myself. It's going to spring from my head, like, from the head of Zeus or something, Athena from the head of Zeus. Don't tell me how to use any kind of methodology of design. I just want to make it up as I go along. Another theory is that the pattern language is somehow defective and it won't work in the built environment. But that doesn't really make sense. Why would it not work in the one field where it was invented and work in all these other fields so robustly, clearly so robustly, generating Wikipedia and everything else? That really doesn't make much sense. And the third theory is really the one that I subscribe to, which is that something very interesting is going on in technology now and in culture. And it's not just Alexander, as I alluded to, it's also Jacobs and Simon and all the other people, Whitehead. And that is, we're beginning to recognize that there's a structure of nature, a structure of the world that we can tap into and we can exploit and we can begin to apply in our technologies, the structure of wholes, the structure of differentiation and of place instead of just standardization and scale. And this is where we're seeing collaborative and management models, open source systems, changes in organization theory, team-based management, Scrum and Theory Z and so on, going back to Peter Drucker and others. I'm sure, Dominic, you've seen that change going on in that field. Manufacturing, one-off, mass customization, as it's sometimes called. And again, this new understanding of the natural processes around us, algorithms, emergence, complex adaptive systems, and so on, and teasing out the real structure that's going on, not as a kind of woozy generalization or, a metaphor for what we're already doing to sort of glorify it or advertise it, market it, but to really understand and to change the ways that we're doing things and the logic of what we're doing. And so I met Ward Cunningham about, must have been about 15 years ago now or so, no more than that, because we were working in New Orleans after Hurricane Katrina. That was 2005. And I reached out to Ward, and he and I became great friends and collaborators, and we've worked on quite a few projects together. He's on the board of our foundation, where we're essentially a think and do tank, as it's sometimes called. And we're developing different kinds of pattern languages and different kinds of wikis. And we've been exploring ways to do that using the web, which is something that I know Chris Alexander was really excited to see happen and to take forward into the world of computers. He loved what computers were doing and what people were doing with computers. And there are still text-based pattern languages. I myself use text-based pattern languages where the nature of a problem is not a static problem, but an iterative problem, an algorithmic problem, if you will. For example, how do you generate row houses individually, one by one, not just as one big building that's sort of a bunch of pretend row houses, but actually different owners, different builders, different architects. And that turns out that takes a lot of sort of generative rules of how do you build the one end of the building and let the next person come in and build the next end? How do you deal with all the fire codes and all the overhangs and eaves and party walls and all that kind of stuff? And so that's a paper version of a pattern language, or of a pattern in this case. A number of others. Here's another one. Some of you, if you're a planner, you may know this idea of taking the space between buildings and putting the property line down the middle and allowing an easement to go in favor of one of the houses, so it becomes the active side of one building and the passive side of the other, and you can activate that entire space instead of having a property line cut it in two, and a number of other similar patterns of a similar nature. So here is what Ward did, though. Ward took forward his original idea of a wiki and made something that he calls a federated wiki, which is basically each page of the wiki is a pattern. And in this example, he actually took patterns from the original book and showed how they interrelate with each other. And he's got the hyperlinks. You can see the blue text there and so on. And so you can put the entire pattern language onto this new federated wiki, which Ward has done, keeping the copyright under control, allowing the original pattern language copyright, but being able to write new patterns. And this is where the exciting possibilities open up, because with the original pattern language, there were only 253 patterns. In the case of software, as I said, there are many tens of thousands of patterns. And of course, we could have many thousands of other kinds of patterns, economic patterns, urban form patterns, more other kinds of patterns. Here's a wiki that Ward designed that he did for Nike, the shoe manufacturer, apparel manufacturer Nike, where they had essentially a sustainability scorecard. And what Ward did is he took that scorecard and put it into the wiki so that each one of the evaluation steps in the algorithm, if you will, is a pattern. And you can look at the cotton fabric, where it comes from, or you could choose the polyester fabric, and then you can sum those together and you can do a calculation, and you can do data calculations between the patterns. This is a very exciting new capability that you not only have patterns that connect to each other in a linguistic way, but they can calculate, they can make calculations, they can model, they can do scenario modeling or very complex kinds of modeling and create visualizations, scatter charts and radar charts and other things. Very exciting capabilities, I think. And then also there are ways of, in this case, doing, as I said, scenario modeling, where you're doing a calculation, and in the different patterns here on the lower part, you can see how the data gets transformed over the series of patterns. It goes through a metabolic calculator, then you look at the metabolic goals, then you see a radar chart or visualization of what would happen in that scenario when you put different numbers into the input of the model. So this is a model, a modeling system, and you put something into the left-hand side and you get something out of the right-hand side. Very typical for any kind of model. You have an input and an output, right? And here's how we did that when we brought that into the world of urban design and architecture, where you could take certain kinds of pattern and start to say, okay, well, let's say we have 3,000 people in this town center catchment area. How about live works? Could you support some live works? How much would that contribute to the economic viability? What about a mixed use building? How many people would that require? And you could calculate the metrics that would be required for supporting that number of people, let's say, or that number of businesses, and use the formulas for predicting that in the scenario. And then you can also upgrade that and improve it over time. This is known as Bayesian statistics, where you start with a Bayesian prior, as it's called, an initial estimate, and then you improve it and you improve it and you improve it, and it gets better and better and smarter, in the same way that Wikipedia started out very stupid, actually, and has become smarter and smarter and quite reliable now in many ways, quite a useful tool for certainly for education and for self-education. And then using project pattern languages, where you're not just, creating some huge ontology of patterns. You're creating a specific collection of patterns for a specific task or a specific scale of project, maybe in the range of 30 or 40, something like that. And I do that in my own work quite a lot, actually. And here's an example of where in Portland, Oregon, they were developing bicycle patterns of how to make more bicycle-friendly streets and street networks, bicycle networks. And here are some of the patterns: bike greenway, median cuts, intersection art, and so on. And you can compile those. You can compile best practices, and different people in different cities could do that and could share with one another and begin to build up a great sort of pattern language or project pattern language for bicycle networks. Biophilia pattern language, this was another little experiment we did, where we took some of the work that's been done in biophilia and healthcare design. Healing gardens, single bed rooms turn out to be very important when it comes to evidence-based design of hospitals for cutting down disease transmission. View to nature, the famous study by Roger Ulrich showing that a view to natural environments actually promotes healing and shortens recovery time. A remarkable finding. And then here is where it got into more of what I ended up doing for my PhD dissertation a few years later. Taking scenario modeling, building this as a scenario modeling tool, and using that to build a community resource. And this was how we started, actually, with Ward and with Chris Alexander and a number of other people in New Orleans, to build neighborhood resource centers or neighborhood renaissance centers, where people could come together and get the resources. They could have a community design wiki that they could participate on and share information on. They could have pre-approved plans that they didn't have to go through all the red tape and get the approvals to rebuild their houses and so on. They could just take parts of that off the shelf that were ready to rebuild. That was a huge problem in New Orleans. And then other kinds of community tools where people can evaluate certain kinds of spaces and develop consensus methodologies for evaluating different parts of their neighborhood. Our colleague Yodan Rofe wrote his PhD dissertation on that idea using feeling maps, as he referred to them. And you could actually have a handheld tool where people go out with their smartphones and the data gets gathered automatically, and they just type in, if their evaluation, their observations, their photos, and whatever. So, you can put this onto a GIS platform. You can begin to use big data tools and smart city tools in a very exciting way, I think, because it's not just gee whiz technology. It's actually addressing what people need when they're in a city or a town or a neighborhood. And then this is the topic that I dealt with in my own dissertation research, was greenhouse gas emissions based upon urban form. And because I had been convinced with my own research and my survey research that I'd done as part of a conference on urban design and climate change, that we were underestimating the magnitude of impact from urban form on greenhouse gas emissions. And I think in my dissertation, I documented that very clearly. But more than that, I wanted to create a scenario modeling tool where you could say, well, what if you attach the homes instead of detach them? What impact would that have on greenhouse gas emissions? What if you increase the density? What if you reduce the infrastructure, embodied energy, et cetera, et cetera? And so I began to experiment with some different scenario modeling patterns and how they could calculate based upon accepted methodologies, accepted estimates. And you, by the way, you can do this not only for something like greenhouse gas emissions, but also for economic returns. And in this case, you can look at how actual infill projects, for example, compare to out-of-town big boxes in terms of the municipal return on the investment. And it turns out, lo and behold, as Joe Minicosi and Chuck Marone and others have shown, that the infill investment, even though it seems more modest, it's a way, way better return on investment to take that approach. So this idea that we are using our technology not simply to create elemental forms that are stripped down and replicated and replicated and replicated, and again, trying to transform quantity into quality through abstraction and repetition, we're moving in another direction now. We're moving in a direction of generating complex forms, sometimes very fractal forms, sometimes very ornamental looking forms, not because we're trying to, put quotes on some particular architecture from somewhere else or some other time, but because we're tapping into the underlying logic that generated those places and would generate new places, recognizing the initial conditions as a whole, diagnosing those initial conditions, teasing out the factors that are contributing to them. And the same way that a doctor says, doesn't just give you a battery of tests, but says, well, how are you feeling today? What's going on? What are the clues? Remember, we talked about that before. And understanding that these qualitative characteristics, although they are qualitative, they're really real. I mean, if you feel sick, it's because you really are sick, right? Unfortunately, we've trivialized the qualitative factors. We've relativized them and said that, they're only in the individual preference, in the eye of the beholder. They're only constructed or socially constructed and so on, which is not to say that there isn't a component of social construction in all of this, but we mustn't kid ourselves, fool ourselves into thinking that it's only social construction, because that is construction in a vacuum. That doesn't explain that there is a natural world, a physical world, a world of health and wellness and well-being and sickness and death. Death and sickness and death are very, very real things. And we can't imagine that we can socially construct those or construct them away. So this is a different way of thinking about designing and building a different kind of operating system, if you will, to create urban and architectural form. And it begins to suggest some of the specific kinds of tools, not only pattern languages, but different kinds of codes that we might use. More of a rule-based operating system, not just parametric codes in the sense of, well, pull the building back to here, or use these sort of parametric values and generate something based on the parametric rules, but more like a bottom-up operating system that is adapting to the result in an iterative way. Remember, that's how fractals get generated and become so beautiful, is that they interact. You generate something and then you react to it, and you generate something else, and then you react to that and you generate something else, and it becomes a feedback cycle that produces this complexity and this emergence and this fantastic structure. And this is exactly what has happened in the most beautiful structures that we can see all around us in the natural world and in the built world. There's great work that's been done on this. Basim Hakim, I commend his work to you on looking at certainly he's looked at the Mediterranean codes and how they have functioned as the sort of rules of a complex adaptive system of the, complexity, and what that means, what the implications are for our own work. And thinking also about not only patterns of form, but patterns of process. And I think this is one of the frontiers of pattern languages. And I want to spend the rest of the talk talking a little more about the potential frontiers of pattern languages and of this kind of methodology that Alexander talks about generative codes, for example, that you can think of design and think of design regulation as not just trying to create a certain static output, but creating a generative process that is going to produce, or is more likely to produce, what you want it to produce. And you don't just set it up and turn it loose and not interact with it anymore, because that would also be a kind of static approach. At least on your part, it would be static. You need to be in the algorithm too. You need to be in the iterative process, evaluating, feeling, judging, changing, adapting. And you and the other collaborators, you and the other participants in that process. And this is very much a design build kind of process, very much like a recipe. When you are cooking, maybe you know exactly what the recipe is that's going to produce the good food, but only because you've already been through it, or somebody's already been through it and has been very carefully going through the steps and tasting and judging and adding a little more salt or a little more this or a little more that, but not too much, because you'll ruin the whole thing, right? So you have to really be in the iterations. You have to judge what is happening and what is the result of each incremental step and how you're going to do that. And then you set that down and you say, add a pinch of salt, or do this or do that. But it's an unfolding process. And this is also what happens in traditional craft, which can be quite sophisticated. We're now beginning to understand that in terms of complex adaptive systems and how that works, how that web way of thinking is actually operationalized in many examples that we can see. For example, let me skip through, because I'm gonna come back to this point again. This is the modeling software that I mentioned. I took it away. So let me just jump ahead here to a conference that we had in Delft University with John Houbraken, who was the head of MIT architecture, a fascinating figure, I think, and a really important contributor and thinker along these same lines that we've been talking about, along with Bill Hillier, another person like that. Bill is on the right here, and John Houbraken is on the left. And so John Houbraken gave a presentation at this conference on complexity, cognition, urban planning, and design. And it was really, the whole conference was about design that is within a larger social and political process, including the process of empowering and affording capacities, getting users involved in the design, designing to enable self-organization. And yes, there's an expressive aspect of it, but the expressive aspect, it has to be integrated into this larger whole, or else it becomes pathological, really. And Houbraken took that point up. He said, complexity in a built environment equates with the number of agents that are in control of parts of it. Distributed agents, not just one person, one controller. The more such agents there are, the more complex the environment is, and the deeper the physical and territorial hierarchies tend to be. And so you can control things in space, you can control the spatial territory, you can control the collective preferences that are, formed collectively. Environments can be compared by the way in which the three modes of control reveal themselves. And that's a promising field of inquiry for those who want to tease out these structures of complexity, as he says. If we compare the contemporary high-density, high-rise environment with historic high-density fabrics that tend to be more low-rise, like Paris or many informal settlements or so on. It may be that the former is less elaborate in terms of the control patterns. Today's environment is technically much more complicated, but technical complexity is not the same thing as complexity by distributed agents. Sorry, that got cut off. To the contrary, there's reason to assume that technical complexity tends to be reduced to lead to reduced distribution of control. Fine-grained, widely distributed control in an urban organism, remember Jacobs here, will improve its durability by its capacity for ongoing small-scale maintenance and renewal, which makes it more resilient and more responsive to new innovations. And if that's the case, we have to seriously consider how higher control complexity can be cultivated. I love that word, cultivated, in a contemporary environment, and how technology can be made to encourage rather than inhibit the fine-grained distribution of control in environmental fabrics. So how can we get self-organization going on in our favor? How can we design for self-organization, if you will? And so we need a cognitive shift, he says, and this really what this course is all about, is this cognitive shift to accept the study of change and control in built environments. And those who seek a successful cultivation of environmental complexity must overcome an ingrained cognition bias. Remember Alexander, and a city is not a tree. We tend to think in trees. We tend to think in terms of neat hierarchies and command and control processes. And we get ourselves into trouble if we don't create counteracting approaches and structures and methodologies. And as Amartya Sen put it when he was talking to students at London School of Economics, show me how your project relates to human life, how it relates to well-being and the freedom to be well, not just what we think of as their well-being, but what they themselves as distributed agents pursue as their well-being. That's how they're going to maximize it. And the freedom not only to be well, but the freedom to lead the kind of life they value leading. Now, you may think of this as a kind of libertarian idea that everybody's just going to go off and do their own thing, and somehow the markets are going to have the magic of the market and everything is going to be hunky-dory. That's not the case, actually. This freedom is a freedom that allows the emergence of what Elinor Ostrom referred to as polycentric governance. It's a constrained freedom, right? Because immediately, whenever you have freedom, you create constraints on somebody else's freedom. Remember, we talked about that before. And the goal is to adapt out the structures that are going to allow me to be the most free when I'm next to you, and for you to be the most free. That's what great urbanism is our ability to be free to lead a kind of life that we value leading. And that's what great cities and great architecture, I think, is all about. Not just creating pleasing sculpture or technological sophistication that in some technical sense meets a lot of needs, because that will lead, as Heybrechen is pointing out, to a loss of complexity, loss of resilience, the Koolhaas problem, individual works of art not adding to a greater urban whole. I think that's a crucial point. And for the last segment, I just want to share with you my dissertation topic and the model that I told you as an example, perhaps, of some of the ideas that we've been talking about in practice, and how at least I, in my research and my methodologies that I use these days, have been applying some of these insights. So Wiki Place is a wiki-based pattern language adaptive calculator of externalities. That's, people love to name their models with these kinds of acronyms, but this acronym has some meaning to me. Obviously, it's a pattern language structure system, and it's an adaptive calculator of externalities. In other words, we're trying to account for externalities like greenhouse gas emissions, or like economic externalities that are, cost to the taxpayer of the less productive form of big box development as opposed to the infill, or externalities of health, or externalities. And you can have negative externalities that are degrading the return on the investment, degrading the well-being, or that are improving well-being. And by the way, I should have explained, I suppose, externalities is a word that economists use to talk about the factors that are not directly within the transaction. So if I, buy a gallon of gasoline or petrol, a liter of petrol, let's say, and I put it in my car and I burn it up, I've paid, whatever I've paid at the pump for that, but I haven't paid the externality costs, the greenhouse gas emissions, the depletion of resources that could have been used for something else, maybe for making, some other critical chemical of some kind, et cetera. Those are externalities. So we need to be able to calculate those externalities. We need to be able to understand how our technologies and our economic processes are actually impacting the world, instead of charging everything to our grandchildren's credit cards, so to speak. And that's what we're doing with externalities. We're simply saying, oh, well, we're just going to emit lots of greenhouse gases into the atmosphere, and we're not going to worry about the externality costs because our grandkids are going to pay those or whatever. Well, we're beginning to pay those ourselves now. I think we can recognize, and it's going to be much, much, much more serious if we don't get a handle on this problem. So the greenhouse gas emissions problem is a very serious problem in its own right, but it's also an example of a systemic problem that is very closely related to other systemic problems like resource depletion, like habitat destruction, like pollution and contamination and invasive species and so on, like other impacts that we're having on our Earth systems. And, we're not having those on other external systems that have no relation to us. These are our systems on which we ourselves depend, and our health and our well-being ultimately depends. Having fisheries, having soil that we can grow crops in, having water that we can irrigate the crops with, et cetera, avoiding huge disruptions and huge human conflicts as a result of these problems that are cropping up of desertification and loss of topsoil and fishery conflicts and so on. So these are all critical issues that we've got to get a handle on. And I think part of the problem, as Jane Jacobs pointed out, is that we lack the feedback systems. We humans have created marvels in creating city success and in creating the other successes, as she put it, but we left out feedback. So what can we do to make up for this omission? And this, in a sense, this tool is a proof of concept, if you will, of a wiki-based pattern language adaptive calculator of externalities. So let me take you through it briefly. So one thing about it that's interesting is that the patterns, in this particular example, I only used 4 patterns because I wanted a proof of concept. And each of these 4 patterns can be seen through Ward's federated wiki, as you see here, and can be displayed on a smartphone app. As we pointed out before, you could use different kinds of tools on that pattern. You could have measurement tools, you could have GIS tools, you could have crowdsourcing tools, all sorts of things that are pretty much anything you could do with an app, right? And Ward was enormously helpful to me in developing these ideas and developing this technology. He really was the mastermind of the federated wiki part of this project. And you remember I talked about his work with Nike, where he did a scenario modeling tool. So this was also a scenario modeling tool, but it was about using predictive algorithms to estimate and to essentially forecast, which is what a scenario modeling tool does, the impact on one particular metric, in this case, greenhouse gas emissions. And that's the idea of calculating externalities, adaptive calculation of externalities, because you're refining it and adapting it as you go. And this is web-based, user-friendly, hyperlinked, wiki open source, incrementally improving, again, following the sort of Bayesian methodology of incremental refinement and improvement over time. So here's one of the patterns: identifiable neighborhood network. You start with a particular scale of neighborhood network, not just the physical structure, but the network of all the streets and all the infrastructure and everything that's in it. And there it is. You can see sort of the whole pattern there with the calculation numbers. Density rings, the different scales of density and amount of, not only just, one degree of density across the whole thing, and also not a sort of fried egg where you have a dense core and a less and less and less dense as you get out, but a polycentric structure, a structure of nodes that have centers and edges to them and that are interconnected in a web. And that's how settlements have always formed over millennia. And it's something that there's good evidence that that's a more optimal urban form, as we show with greenhouse gas emissions. Web of shopping and activities, obviously you need those things near you if you're going to be able to have a viable neighborhood and able to get to all your resources efficiently without consuming a lot of resources to get there. And this is the idea also of the 15-minute city or the 15-minute neighborhood, that you could get around easily and get to your resources. And then web of transportation, which means not only on foot and on bike, but also on public transportation, and the car also. We're not excluding the car, we're just saying the car should be only one choice, and it should be perhaps a much more limited choice because it does have these enormous externality costs that we haven't factored in. So let's tame the car, let's make places that are more livable, more beautiful, more attractive, more desirable, as they often are when you create these kinds of communities. They become very sought after, popular places. And so these are the major patterns. And then here's an example of how it works in the actual scenario modeling processes. You can see there that over to the left are some of the sort of introduction and orientation pages, and then you go into the actual patterns, and then you can see where the calculations actually occur. And what's happening here is that on the left-hand side, you're adjusting the input, and in each case, you're adjusting what in that scenario you want it to be. What is the size of the neighborhood or the population of the neighborhood, the density rings, the web of shopping and activities, and so on. And then it's applying a predictive algorithm to say, here's what the research suggests the greenhouse gas emissions per capita in that area will be as a result, what the reduction will be, what the delta will be. So you start with a baseline of what the population in that area is already generating, and then you apply the delta to see whether it's increasing or decreasing based upon the changes that you've made at each scale of the scenario modeling tool. And then finally, you get a predictive outcome from that. And in my case, I took 3 different tests of the models: country to city comparisons, city to city comparisons, and neighborhood to neighborhood comparisons, and got very good results actually based upon what the empirical findings were, which makes sense, of course, because I was using some of the empirical research to calculate in the model, using the methodology for calculating those deltas. And lo and behold, we had very good statistical deviations of only 17.0, 5.3, and 7.1% from the known inventory data. Now, this is early days, and there's a lot of issues about various greenhouse gas inventories and whether they're apples to oranges, whether they're consumption based, or there's a lot of apples to oranges and other issues. There's a lot of important work that needs to be done, and it is being done to refine this. But I think where we're going with this is and again, it's early days, but we have methodologies now. This is a charrette process that we did with our colleagues to do scenario modeling and to do a pattern language. In this case, was just a paper-based pattern language that we used for a redevelopment of an airport project. And to give people the power as a community, as a neighborhood, as a region, even in this case, to collaborate and to participate in the development of a final design, and to maybe jump in and, at the polycentric scales of building, to become participants in that process and begin to build different pieces of that process. They're actually having their grand opening next week, in fact. So that's, I skipped around and I went to the bit about John Houbraken, but that I think is a good place to, I think that's a good place to end on. And I think maybe we have another 20 minutes or so to reflect on this, and for you guys to give me your comments and your thoughts. I apologize again for the lateness of getting the papers to you, and also the recording from the last lecture. I know there's a lot there, a lot to unpack, and I would be interested to hear your comments on today's lecture and on the previous lecture as well. So Dominic, do you want to, since you're the one who is really working with management theory, and you've heard a number of discussions of that about, some of the new team-based management approaches and the Scrum and total quality management, et cetera. What are your thoughts on that?
Thank you. To answer your question from today's lecture, yes, I have heard of Agile methodology, and so far I have identified it primarily with information technology and project management as well. In your class, I see more applications of this methodology in other significant areas, so thank you very much. And as far as the pattern language is concerned, it is a very fascinating and useful topic, because basically everything around us is a kind of pattern, I think. In the most basic sense, all national languages are pattern languages, as they are made up of letters of the alphabet that have a particular shape and semantics. Already the most exemplary national languages were the Egyptian hieroglyphs, as well as the Chinese, Japanese, and Mayan alphabets, which are also exemplary. But coming back to the more modern concept of pattern language, it provides an excellent sort of instruction manual for coding, writing various rules in programming languages, and creating software to solve complex problems, not only from the technical point of view, but also in management. On the other hand, pattern language is also the basis for mathematical modeling, where each variable is assigned to a specific meaning, and where each variable have its specific parameters. My undergraduate thesis was on applications of mathematics in medicine, specifically mathematical modeling of cancer growth. And the mathematical formulas and models analyzed were then fed into computer software. Thanks to it, I saw the importance of patterns in translating mathematics into reality. And I see also that in management, some kind of patterns and mathematical models can be considered, so that each topics presented here combined together, and I see the complexity and the fascinating matter of it. So thank you very much.
Yeah, well, we'll talk more in future discussions about symmetry as a sort of overarching idea in mathematics and in physics and in information theory and in many other fields, and in architecture. And that doesn't mean just left and right symmetry, reflectional symmetry. It's many other kinds of symmetry, and mathematics is essentially symmetry. What you're doing is you're creating an equation, equating one side of the equation with the other in a symmetrical structure, and other kinds of symmetries within the within the formulas that you're writing. And those symmetries are not only, between the two sides of the equation, they're also with some reality that you're dealing with that captures some essence of the structure that has a symmetrical relationship to it in such a way that you can accurately capture some of that structure in a useful way. And then here's the mind-blowing part of it. Then you can change the reality. This is what I refer to as the architecture of possibility, that language, including mathematical language, creates an architecture of possibility, because once you have articulated that structure, you can now change it. And you can change it according to the logic of your language, which might be somewhat different than the reality. More important, it is a language. It is different in that sense. It is a way that we human beings tease apart the structures that are there in the universe and interact with them and work with them and create new possibilities. So, I use the example, if I'm going to meet you at 2:30 tomorrow, you say, no, I've got a Zoom meeting at 2:30. How about 2:20? We've just created an architecture of possibility. We're changing reality. We're transforming reality through the linguistic structures that we use. And the linguistic structures are themselves creating not only limitations on what we can do, but also expansions of what we can do, enormous expansions of what we can do. This is the great power of language, I think, and the great, open-ended nature of it, the vastness of the possibilities that we can create, and in language and in the arts, and because of course the arts are a kind of language too, an expressive language of form or of music or of those are all also generative structures that transform reality in a certain kind of way, in a way that is based upon our ability to manipulate language. So I think certainly in Alexander's work, the idea of language and the deep structure of language and work that Noam Chomsky and others have done on that is very, very powerful and very important in their thinking. And I think also the idea that we can understand the nature of the problems around us and not get hung up on the artificial aspect of our language, because language can be dangerous too. We can get lost in our linguistic constructions and fail to see the reality. Alfred North Whitehead referred to that as misplaced concreteness. We misplace what is the concrete when we're working with abstractions and with language, with linguistic structures. He talked about how using language is a little bit like taking a trip in an airplane. You take off and you soar way up above and you could see things down on the ground that you never could see before. And now you can begin to see how they could be changed and how you could maybe reconstruct things if you wanted to, if you're a city planner or whatever. But you better come back down and land the airplane. You don't want to get lost in the clouds. And this is what happens when we commit the fallacy of misplaced concreteness, as Whitehead referred to it. And Wittgenstein also was very famous for saying that philosophy is the battle against the bewitchment of intelligence by means of language, the battle against the bewitchment of intelligence by means of language. And I love that because it's a double entendre, right? Because the bewitchment of intelligence happens because of language. We get caught in our language. But really, the only thing we have to battle against this bewitchment is our language. So we have to actually, take the bull by the horns. And that's what philosophy is, according to Wittgenstein. I think that's a lovely idea and a very, very important idea that we need to get this right. We need to get the relationship between abstractions and linguistic constructions and artistic expressions and all these other things that we humans create that we construct, socially construct, and construct through symbols, and the reality that we are immersed in and that we are continuously transforming and interacting with, in order to make sure that we don't get into trouble and don't harm ourselves or destroy ourselves, destroy our world, and that we actually create a more beautiful world, a more robust and healthy and successful and livable world, which we've been able to do to an incredible degree. If you see how wonderful and beautiful and fantastic so many cities and towns and buildings have been and can be, and how much human culture can be, it's exhilarating and it's breathtaking. But it also is a moment, I think, of extreme danger for humanity, that we have become so successful with our technologies, and especially our more elementary technologies of standardization and economies of standardization and economies of scale and economies of stripping things down into elementary relationships. The earlier stages of the sciences, the 2 variable and the statistical variable, and we've created a whole world around that now. And it's been an unbelievably productive and unbelievably successful in a certain sense, and yet catastrophically unsuccessful in another sense, in the sense of the direction that it's headed and what the impacts are going to be, the externalities are going to be, if we don't get a handle on that very promptly. And so I think, there are aspects of this that we touched on today, and we've touched on throughout the course. There's, the issue of greenhouse gas emissions and climate change, which is a profound challenge, I think, to our own ability to control our own impacts. If we can't deal with that, we're really going to be in trouble as a species. And it's not the only issue that we have to deal with. As I said, we have resource depletion, we have habitat destruction, we have contamination, pollution, invasive species, all those kinds of things. And we have the erosion of some of the cultural institutions that we must rely upon to deal with all those other problems in order to make good collective decisions, in order to understand where we are and what we need to do as individuals, as groups, as states, as nations, as a global community, as a species. And if we can't do that, I think we're done for, but I don't think we are done for. I think we're going to do the right thing in the end. There's an old saying that people can be counted on to do the right thing after they've tried everything else. And I think we're trying a lot of other things before we get around to confronting some of these problems and some of these issues. Anna, do you have any comments on your work and what, I know there are some issues there about, and we talked about this before, about how architects as a profession have a particular culture, a particular way of seeing the world. And that can be teased out further as it's not one big amorphous group. It's also different schools and different eras and different countries. And, and we briefly touched on the fact that in Poland, you have so many different periods, especially in the early 20th century, going up to the, through the period of social realism and mid-century and so on. What are you finding in your own research that you're finding interesting, and maybe anything that we're talking about in this course that you wanted to touch on?
Yes, Professor. Well, at the beginning of your lecture, you've touched the important topic of the responsibility of an architect. And I finally, a few days ago, I had an information who will be probably reviewing my PhD. And I was surprised to know that this is Professor Konrad Kuczyński, who actually was a part of Association of Polish Architects. He got an important prize. But then when he was in his 70s or now he's in 80s, he decided to sign off because he didn't necessarily like the way that they allow things to develop in terms of blocks, flats, these floor plans that are flying around. We have a significant problem with that.
Yeah.
So it is because I agree with him that it is hard to see it as a progress in any way, because we have all these studies about the comfort of life, and then we decide to cut off the space to the extreme minimum. I know this is driven by different factors, but then we are the creators of the space as architects, and we allow that to happen. So also one thing that struck me during this lecture was that, well, after the modern times, let's put it in short that way, I think that we as architects didn't have much progress in terms of materials, methodology, methods of design, software. We are kind of stuck in this. I don't see, when I analyze these houses that I have in my case study, there is not a significant progress, and almost 100 years has passed, right? So this is another problem that I see, and I'm thinking why we don't have that progress while we have all the I think that we have all our studies that were done before. We have some software, but in the end, we decide not to really rely on that and still be creative, as you said, and fall into the same mistakes as we did 100 years ago. And this is something that I just cannot wrap my head around it. And another thing is that now there are not much architects that are scientists who study the design process in a way that it was done in the modernism. And then they implement the theories through the design. And I'm curious, why is that? Because I know that after modernism that there was a postmodern time, but then I don't see much progress, and we are even struggling to name the era. We still call it postmodern, right?
Yeah.
So I think, what are your thoughts on that? Because it is hard for me to process, as now I've realized that not much progress has been done since then. So
yeah. I think that's true, and I think there's a couple of interesting aspects of that. Jane Jacobs talked about, in some cases there's outright retrogression, and perhaps what it is that we in the design professions and architecture in particular have embraced an image of modernity, an image of progress, and sort of used that as a as a kind of shibboleth or a kind of magic word or something that we've clung to it in a way, clung to this sort of dying ember of idealism from the early 20th century, even though we don't have any real reason to believe in it anymore, the sort of rational ideal of the radiant city or whatever. But it's still a potent marketing idea. And unfortunately, that ties into another thing going on, I think, in our world, which is something actually the anthropologist Edward Sapir described, the growth of what he called spurious culture. He was a cultural anthropologist who studied a lot of linguistics. He was famous with Benjamin Whorf for the Sapir-Whorf hypothesis, which became very unpopular, and now it's coming back a little bit in terms of how language influences thought. Maybe it doesn't determine thought, but it influences thought, and certainly influences what we think about and what our concerns are. And what Sapir described is that there are these cultures throughout history, whatever their flaws are and whatever their evils are, often slavery and whatever, they had a kind of wholeness about them that we are now, for some reason, lacking in our culture. And we are, I think it does have to do with we've allowed these sort of viral processes to spin out of control and to strip away, almost like enzymes, the connective tissue of our culture and the wholeness of our culture, and to create these sort of spurious byproducts. And one of those is the sort of the world of consumerism and everything being about marketing and being about image and being on the surface and not being about the deeper issues, and also being about money. And money, I think there's nothing wrong with money as a feedback system, but it's not the only feedback system. If we suddenly value that more than anything else, more than honor, more than a sense of job satisfaction, more than a sense of being a craftsperson, you know, being all the other things that we get from economic activities and from interactions with other human beings, then we're idolizing money. And the religions have talked about that as a sin from the beginning of time, that you shouldn't idolize money, but that's what we're doing. And so architects sometimes idolize money. They idolize the idea that they're branders and themers, and that their art is now, they now have this blank check, this artistic blank check to create this razzle dazzle, whoa, look at me, and so on. And also to sort of go back to the past in a way, not to the, well, sometimes it's even to the, you know, the sort of Disneyland past, if you will, but more likely it's the past of the progressive era of modernism, and saying, you know, yes, we're still saving the world and we're still wonderful, look at us, and we're the masters and we're the form givers and we're the great artists, and all of this stuff that was really ascendant in, you know, the 1930s, sometimes in very frightening ways, you know, became this seductive dark side, if you will, of the profession that has come to dominate in many ways. Not to say that there isn't, you know, good reason for people to make those choices in the context they're in, their bounded rationality, their inability to see alternatives. If you're a professional and you're sort of stuck in that world, I mean, Frank Lloyd Wright, for example, went through this process of where he was being told by his friend Mies van der Rohe, oh, this is the way the world is going and you better get with it. And he resisted and resisted and resisted. And finally he said, all right, I'm going to show you guys, I'm going to do you one better. And he did Falling Water. And then he did all these other amazing projects that were in the you know, modernist mold of that time. So we all have to sort of live in our worlds that we're in. But the question is also, as professionals and as citizens, should we not also be transforming our world and reforming our world when we need to? And I think certainly what you see in this discussion is that we in the design professions, especially in the built environment professions, we've really gotten caught up in some of the dysfunctions of our culture and of our economics and of our, you know, real estate development processes and the operating system for growth, as I've described it. And I think it's our job now, I think it's our duty actually to dedicate a portion of our lives and careers, at least, if not all of them, to finding ways to reform this failing system, because it is part of the larger challenge we have in this time. And I think actually, to bring it back to the topic of the course, this is what the New Urban Agenda is also trying to address: how to put our culture and our civilization and our technologies on a more sustainable, more durable, more humane footing, and to avoid the catastrophes that might otherwise befall us, could very well befall us if we don't act responsibly. So that's a good note to end on. I think we're already a couple of minutes over, but I will get this video done more promptly today. My apologies for the delay in getting you the one from the previous lecture. and I'll do that. And then I will see you guys on, I think we're back on Monday, aren't we? Let me
Yes, Monday.
Monday. Okay, so I will see you at the same time on Monday.
Thank you very much. Goodbye.